Assalamualaikum and hello to our lecturer, Miss Sumaya binti Mashuri. We are from Group 4 and we will present about summarization of PLC. The bio you see now on the slide is the face and name of each member of our group, which is Nur Rasha Afika binti Ahmad Jahid, Tang Lok Yuan, Chan Siriko Justin, and the breakdown of the week that we will present for this task. In week 1, we had known about PLC, Festo company, and also the manufacturing process that had been used in industry process for many years, which is pneumatic and hydraulics from the industry talk. Which topic is the pneumatic and hydraulic application in the industry by Mr. Azhar Abbas as sales manager in Festo company. Then we have to build the mind map as our individual assignment in week 1 for knowing our understanding from this talk. For week 2, we get know about the lesson plan of this subject and information about activities that had been done, such as programmable HMI touchscreen LCD under the mentor mentee program and how the grouping method will be marked. In week 3, we know about the introduction of PLC. In chapter 1, part 1, we know about what is PLC, application of PLC, and advantage of PLC. PLC is an industrial digital computer which has been recognized and adapted for the control manufacturing process such as robotic device. There are many applications of PLC. For illustration, is oil and gas pipeline transportation, wind turbine operation, cement manufacturing, and smart factory. The advantage of PLC is it is flexible and robust control solution that can adaptable to almost any application. It is grand because it is understood programming language. It easily to troubleshoot and provide function that can check condition. Next, for chapter 1 part 2, we know about the PLC system, scanning operation, and I/O memory reference. System is start from power supplies, memory unit, central processing unit that called CPU, programming device, input button, and lastly to output device. There are two types of scanning operation. Firstly is horizontal scanning order that examines input and output instruction from rung by rung in horizontally, while the second scanning operation is vertical scanning operation that examines input and output instruction from column by column in vertically. For I/O memory reference, we can know the detail of input bits and output bits in PLC program. Example, in CPU1E that have 20 I/O memory units, it is have 12 input bits and 8 output bits. We're also familiar about the Omron CP series CPU1E CPU units and understand the feature of CPU1E E20STRA. There is renewable basic model, and the CP1E N20DRA is normal application model. In week 4, we are exposed to CX programmer. There is programmer tool that we use for creating, testing, and maintenance our PLC, and SOP for creating LD, and also SOP transfer to PLC and simulator.
Hello, my name is Chan Siriko Justin, AN190099 from Group 4. I am going to talk about my part, which is in the week 5, which consists of the chapter 3 PLC programming. First of all, ladder diagram is commonly used to document the industrial control logic circuits. It is called a ladder because they resemble a ladder with the two vertical bus bar, which is a power supply, and it has many rungs, which is the horizontal line to represent the control circuits. In the PLC, the settings that we use are the device type name Omron CP1E, and the CPU type is the E20, and the commonly used address for the input is the 0.00 until 0.11. For the output is 100.00 until 100.07. And as for the internal relay, it is anything from 0 to 199 except for 0 and 100. Next, moving on to the basic logic function. As we can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 basic logic functions. And this is the examples of the basic ladder logic instructions. This is the LD, the LD load, and this is the LD not. This is LD N not. This is N. This is or not, or LD, NLD, and the output. And next is the ladder logic instruction, where we have learned the ladder diagram, how to do a ladder diagram, and how to write it in a mnemonic code. This is an example of a ladder diagram and a mnemonic code table. In the week of 6, we have been given video for case study. It consists of float center application, latch push button application, traffic light application, car application, machine application, and the first question is the next question is the push switch, which is start button is used to start a motor, and another pull switch stop button is used to stop the same motor. Assuming the start and stop button are physically normally open type. And the push switch start button is and next the question is the start button is used to start the motor, and another push is used to switch off the motor. And with this case study, we have been given tasks to identify the input and output to do the Boolean expression, and we also been given a task to do the truth table, the ladder diagram, and we need to analyze each of these cases. Week 7, we have learned about PLC instruction. First of all, we need to learn about the cycle of program development. First is the writing and editing step. All program tools have one or more editors. These are user interfaces where the program writer constructs a program code. It can be a simple editor without graphical symbols, or an editor that is equipped with programming in a graphical language. Next is compiling and linking. A compiler is a program that converts code to machine code, which is a code that is used in digital equipments such as PLC. Next, if the source code contains error, as a result of violation of the rules, it will generate error, and the error is called syntax error. It is because the lack of variables or calling a function or subroutine that does not exist. Next is uploading and running. When the code is free of syntax error, the machine code can be loaded to the PLC. And note that many programming can be simulated using its own simulator, so the user can test the code without loading it first to the PLC. Moving on to the debugging, most development tools for PLC contains tools for troubleshooting. Usually, programmers call this as debuggers. It is involved of hunting or correcting these errors. Let us move on to the ladder logic structure. The ladder logic structure is bounded by vertical lines that is called as an busbar power supply. The busbar power supply on the left always has a state true, and it is considered to be a voltage that have 24 volt connected to the bus bar, while the bus bar on the right has no defined logical state under any standard. It can be, therefore, considered as an implicit and not at all producers implement a vertical right line in their development tools. Generally, a code in a ladder diagram is based upon the following principles. If a condition or combination of a condition is satisfied, then there will then the code can be performed. And lastly, rung is a logical unit in a data diagram, which it can compass one or more rows and columns, and these rungs are numbered starting from 0 and so on. This is the example of the ladder diagram, and this is the bus bar, and the horizontal line is the rung. Let's move on to the typical mistakes that usually students make. We take a case study which two normally open contact switches is used to control the circuit. If at least one of the switches turn on, the motor should start. And the example that students always do is like this, where it consists of two rungs, which is rung 1 and rung 0 and rung 1. The solution for this mistake is we make it as just one rung, where we collect the conditions for the control on the output. So let's move on to the examples where we learn about example on simulator, hardware connection, and how to use keep, which keep is same as latching, but it is used to replace normal latching because there are two inputs, which is set and reset.
Hi everyone, my name is Tang Lo Yun. I am one of the members for Group 4 for this group project of programmable logic control. For now, I want to share with you how we have done in week 9, from week 9 until week 12 of this syllabus. As you can see, in week 9, we do our group assignment PLC design project. So now I want to share with you the discussion of this group assignment. At the end of this activity, students are able to analyze the PLC programming using Orange CP1E series to control an automation system for various applications. Second, programmer testing and troubleshooting the error in PLC programming by using CS programmer software to solve the engineering problems. Third, observe and analyze the operation of the PLC programming by using War Online Simulator and make necessary modifications based on the case study. And the last is we are able to respond in a group effectively by solving the assignment and case study or project given. Next is the characteristics of this group assignment. For the purpose is to motivate the creative application of knowledge, enhance problem-solving skills, and apply real solutions to real needs. Students will expect to complete an extensive PLC design project based on the topics covered in the PLC course. In the next is the few examples for us to choose as our project title. There are arrangements for separating similar boards, washing machine, traffic light sequence, car park, parallel operation, photo packing, and the last is the liquid level monitoring. For now, I will share with you the what we have done in week 10 of this syllabus. So as you can see, we do our group project in week 10. So this is our title, packaging system with counter. For the objective of this project, to implement programmable logic control PLC program that facilitated the manufacturing industry in the process of packaging products. Second, assist the manufacturing industry in sorting of packaging according to the prescribed quantity. Lastly, avoid mistake in quantity of the products during the packaging process. There are the list of the equipment used in our project: proximity sensor, conveyor, solenoid, products, and the box. This is our input and output. For the input, uh, we have push button sensor, and the output we have conveyor motor, solenoid, internal relay, counter, and the timer. And the next is the process sequence description of this project. So in input, if we press on our push button, the internal relay become high and conveyor motor energized. Second, if sensor detected the product, a counter with countdown for 5 products. And the next is the counter finish count solenoid with extra for 10 seconds. And the next is the timer. If timer times out, the solenoid with retry and reset counter. And the last is with press on the off button 0.01. The conveyor motor will be stopped uh, or reset the operation. So this is the reference of our group project. If you have extra time, you can refer these two links to understand what we have done. Therefore, in week 11, we have talked to the academic industrial talk. The title is PLC as SCADA application from industrial perspective and experience sharing. For the panel 1, he shared the PLC application for industrial perspective and experience sharing. And the panel 2, Natasha, she shared the SCADA application for industrial perspective and experience sharing. For panel 1, Muhammad he has shared what is the responsibility and duties of a programmer in electrical department. First of all, he had to supervise machine assembly and installation. Secondly, responsible for all electrical activity in job site and assembly area. And the third, preparation of project quality plan, project report and documentation. And the next is preparing, updating project timetable on daily, weekly, and monthly progress report to ensure that the project is within time cost and to the quality requirement. Then lastly, to work with the customer during machine development process, providing design expertise and support. And also, he shared the programmer edition to understand concept of For new test, issue electrical standard part, design control panel, operation panel, electrical circuit diagram and I/O assignment, develop ladder diagram for system and design HMI, transfer program to PLC and HMI setting, parameter if needed. There are two methods to program sequence in as a programmer. For the first is the conventional method, and the second is the shift method. And this is the description for the method, for the two methods. Conventional method, it can be track and reject container, but it is more complicated than the shift method. So the shift method have the same function with the conventional method, and it is more easy to understand by the others. For the panel 2, share the PLC, common PLC in industry. There are Oro, Siemens, Siemens, Mitsubishi, Helen Prelli. She had analyzed the different type of PLC. First of all, we have to know the PLC model with the PLC brand. Secondly, Google the datasheet, user manual. And the third, download the software for. And then lastly, to watch online tutorial. And the next is the component SCADA. And what's the meaning of the SCADA? SCADA is supervisory control and data acquisition. And the component is SCADA. There are sensor, manual inputs, PLC or RTU. And the last is the HMI SCADA benefit. First of all, reduce labor costs, increase output production, improve quality product, and the last is the reduce accident risk. Also, as mentioned, the career requirement in the company. So these are the position and also the requirement. And the next is the career advancement in control system engineer. So, and the next is the challenge as control system engineer. So if you explore time, you can refer to this link to more understand of what we learned in this in week 11 of the. At the next, there are few PLC applications that we have learned in week 12. They are latching circuit, sequence motor control, PLC conveyor motor, semi-automatic liquid mixing application, and the last is the interlocking motor circuit. For the latching circuit, I've do the analysis for this PLC application. If the start button is pressed, current will flow to the NC stop PB and activate motor starter coil. Hence, latching circuit not contain end with change to close. And the next, if stop PB is released, the current still flow through the latching circuit and activate the motor starter coil. And the last is when stop PB is pressed, the current is in the lock. Motor starter coil deactivator and latching circuit and back to normal condition. And the next of the PLC application is the sequence motor control. I have to do the test, process sequence description, and also the analysis. So I do a few explanation in process sequence description. If we have input start button is pressed, the output, which is the motor 1 will turn on and the timer 001 activator for 5 seconds. And the next, if timer 1 times up, the motor 2 will turn on and the timer 002 activator for 5 seconds also. And the next, if timer 2 times up, the motor 3 will turn on. And the last, if we press the stop button, it will reset all operation. And the next is the PLC profile motor. So if you have extra time, you can refer back to this test process sequence description analysis of this PLC application. And the next is the semi-automatic liquid mixing application. So in test for this application, pure unmixed solution can be prepared by the operator using switches S1 and S2, and mixed solution or material can be prepared by the operator using switch S3. S1 is used to activate V2 while S2 is used to activate V4. The interlock system is provided so operator cannot operate by both switches at the same time. The operator will observe the level of the tank and it can discharge the liquid inside the tank by operating valve V5. Detector motor M1 will be in running mode while tank is being filled. V1, V3 and V1 are manual field which is not connected to the PLC. And lastly, V2 and V4 are electronically operated fields which can be controlled by PLC. And these are the process sequence description and also the analysis. And the last of the PLC application is the interlocking motor circuit. So there are two types for this PLC application, and this is the process sequence description. And the last also I share the analysis for this interlocking motor circuit.
In Unit 13, we revision about the whole semester. We know about the CP1E30 that have 30 I/O, have the input be cover channel 0 and 1, output be cover channel 100 and 101. We also know about the impact when we use the same input and output address. So we have to make sure we use the input area between 0 to 99 and output area between 100 to 199 for avoid the input and output address in hardware having the troubleshoot. We also know about the later dominant on is when we push the start and stop button as a high value, the program will still on, while the dominant off is when we push the start and stop button as high value, the program still off. We also revision about the similarities of internal relay and keep. When the start push button in low value, the program remain on until the stop PB is pressed because the dominant part in internal relay is contact while keep is stop PB. The other point that we revision is the normal latching is the letter that have call and contact in one round that usually use internal relay in that latching. Lastly, we also know about the sequential instruction set. There is keep and interlocking motor. For keep, if start and stop button push simultaneously in low value, there is nothing happen in the program because keep will remain value 0. Next, the other point for keep is do not reset stop PB as normally closed because the dominant part in keep is in the reset, so the program will not run if we put stop PB as normally closed. Interlocking is used to state storage at branch points. So for the interlocking motor program that have 3 motor, this operation will only allow the 2 motor run simultaneously at one time, while the other one will run by itself.
In the week of 14, we have been given extra notes on process sequence description, which consists of timer and counter. We have 4 different situations. First of all is the single acting cylinder, which the task is when the start push button is pressed momentarily, the piston rod of the single acting cylinder will advance and the piston rod will remain at the extend position for 10 seconds and then automatically returns. And as for the lamp 1, will be activated when the piston rod retracts and remains on until the push stop button is turned on. Next is the process sequence, where the start push button is pressed and then the cylinder advances, the timer active for 10 seconds and then after 10 seconds it will retract and the lamp 1 will on. Until the push button is pressed, it will reset all the operation. Based on the analysis, when the start push button is pressed, timer 1 will activate for 10 seconds and the cylinder will extend. Even the push button start is released, the system will continuously run due to the normal latching. After 10 seconds, cylinder 1 will retract and lamp 1 will return on. Lastly, when the stop push button is pressed, all the system will turn off. This is the example of the ladder diagram. And moving on to the second question is the single acting cylinder with counter. The question is the same as the first one, which is the single acting cylinder, but it will use counter where it will repeat the process for 3 times. In the process sequence description, there is only one thing added, which is the after 10 seconds, the 10 seconds of the timer of 001, the CNT 002 count will begin count for 3 times and the lamp will turn off. After 3 counts, it will reset all the operations. The analysis is the same as the single acting cylinder, where it is only added with after 10 seconds, the TIM001, the CNT002 will count 3 times and the lamp 1 will turn off after the 10 seconds. After 3 counts, it will reset all operation, and while the press push button is turned on, this press is pressed, all the system will turn off. Next is the automatic filling bottle system, which the task is the start push button is used to start and stop the process. When the start push button is pressed momentarily, the conveyor motor for the automatic filling bottle system will start moving until the proximity sensor is activated, where it detects the bottle. When the solenoid valve will open for 5 seconds to fill the bottle with water. After 5 seconds, the conveyor motor will move again, and then all the process will be repeated twice. if the start push button is pressed and the operation will be reset. The process sequence description is the start push button is pressed, the conveyor motor is moving, and then the proximity sensor is activated. After that, the motor will stop and the solenoid valve will open and it will stay active for 5 seconds. After 5 seconds, the CNT00200 count 2 times, as it will repeat for 2 times. And then the solenoid valve will close. After 2 counts, it will reset all operations and the start push button. After stop push button is pressed, system reset all operations. Based on analysis, on round 1, when push button is pressed, round 0, push button is pressed, round 1, conveyor will start moving and due to the normal aging, it will still remain on. After that, the proximity sensor will stay active and the conveyor motor will stop. And moving on to the next question is the interlocking of two motor controls. This consists of two sequential tasks for interlocking two motor controls. As there are two motor and two motor will start on its own and it will stop when it is pushed on its own. And for the safety purpose, interlocking system is applied to ensure the system only allows one motor run at the same time. This is the input and the output. And based on the analysis, the systems only allow one motor to run at the same time, as we need to add each interlocking system in each run. So in motor 1, we add normally close contact to the motor, normally close contact of motor 2, and motor 2 we add normally close contact of the motor 1. When the start push button of motor 1 is triggered, then the motor 1 will start. At the same time, when the start motor 2 is triggered, the motor 1 will remain on, but the motor 2 does not operate because of the interlocking in the motor 1 in open contact, and so on to the motor 2. In the week of 15, we have conducted an oral test, and this consists of our group, which consists of Hasha and Tang and me. And in this oral test, we have been given a simple narrative, which is this is the question, and the question is, when we press the push start button, the cylinder Y0 will turn on while the cylinder Y1 will turn off, and the timer 1 and timer 2 will be simultaneously started, but the timer 1 is active for 5 seconds, timer 2 is active for 15 seconds. After that, after 5 seconds, the cylinder 0 will turn off and cylinder 1 will turn on. And then after 15 seconds, it will repeat the step 1 for 2 cycles because of the counter. After 2 counts, it will reset all of the operations. And if the stop button is pressed, the whole operation will be reset. And through this oral test, we have conducted our troubleshoot and we have done so many errors. And this is our first try on our to do the ladder diagram, and as we can see here, we failed to do the correct ladder diagram. Ladder diagram, same with the simple narrative. And then next is our uh, next is our second try, which uh, we change the round 1, round 2, and round 3. And this is also cannot be used because it does not uh, corresponding to the simple narrative that has been given. But in our third try, we have successfully um, completed the simple narrative, and this is the example of our success. And if we push the start button, it will turn on the cylinder 0 for 5 seconds. After 5 seconds, the cylinder 1 will turn on. And then after 15 seconds, the counter will be count for 2 times, and it will reset the whole process. As we can see here, the cylinder 1 just recently turned on, and then the timer is also simultaneously turned on.
That's all from us. Thank you for hearing.